Okay, this is the start of chapter 7. In this video, we're just going to do the first section, ion formation. Okay, the objectives, we're going to define what a chemical bond is, describe the formation of positive and negative ions, relate ion configuration to ion formation to electron configuration. Okay, remember what the octet rule is. Atoms tend to lose or share electrons in order to get 8 valence electrons. We're going to go over all this vocabulary, a chemical bond, cations, anions, electron affinity. The main idea here is that electrons are formed when atoms gain or lose valence electrons to achieve that stable octet. They follow the octet rule for their electron configuration. Okay, so the definition of a chemical bond is a force that holds two atoms together. It could be two or it could be more, at least two, sometimes more. Okay, so these chemical bonds are formed by the attraction between the positive nucleus of one atom and the negative electrons of another atom. Okay, so really it's just the interaction of these valence electrons between two or more different atoms that creates a chemical bond. Okay, so the other thing we need to talk about here is electron affinity. They mention this in this chapter and in your packet for the homework. And that indicates, electron affinity indicates how much attraction atom has for an electron. The higher the number, the higher the attraction. Okay, this is very similar to the electronegativity we had in chapter 6. Okay, so electronegativity and electron affinity, pretty much the same thing as far as we're concerned. Okay, so halogens and other nonmetals generally have a high electron affinity. So these are the ones, the halogens, remember they're group 17, they just need one more electron to create the octet. And nonmetals are generally on the upper right side of the periodic table, not including the halogens, not including the noble gases, I mean. So they want to grab one or two or maybe 3 electrons. Okay, metals, on the other hand, have a low electron affinity. They are on the left side of the periodic table. They usually want to get rid of 1 or 2 or 3 electrons. So they're not really interested in grabbing another electron. And the noble gases really don't play a part in this. They have a very, very low electron affinity. Okay, so the atoms try to form an octet. That's the stable arrangement of 8 valence electrons in its outer energy level. They do that by gaining or losing valence electrons, and later we'll learn that they also do that by sharing. Okay, so this electron dot structure for the period 2 elements, right, starting at lithium and going over the neon. Remember, it's just the valence electrons. We put the symbol and however many valence electrons they have around it. Remember, we start out with 1, 2, 3, 4 single electrons, and then we start to pair them up till we get to 8. Okay, so a positively charged ion is called a cation. Okay, C-A-T-I-O-N, cation. This happens when an atom loses an electron. It becomes a cation, right? It loses something negative, it becomes positive. Okay, this little figure over here, we talk about sodium losing, starts out as a neutral atom with 11 electrons, 11 protons. It loses one of these electrons, okay? And this is the ionization energy it takes to do that, kilojoules per mole, well, don't worry about that. So it forms this positive ion, and the kind of the chemical equation for it is here. The sodium plus the ionization energy creates a sodium ion and a free electron. Okay, the way I remember this is a cation is positive is the T kind of looks like a plus sign, right? So the cations are positively charged ions. They have lost one or more electrons. So the T looks like a plus sign. Okay, so metals are most of the metals are very reactive because they lose these valence electrons easily. So the group 1 and group 2 metals, the alkaline earth metals and the alkali metals, they both want to lose those electrons. And even group 13, they tend to lose those 3 electrons also. Transition metals, these are group D elements, right? Between the groups 3 through 12. They generally form ions that have two, they usually lose 2 or 3 electrons to form positive ions. But sometimes, depending on the electron configuration, they can even lose more. And one of the other things that happens in these transition elements, especially in the group 12, the zinc group, right? This is the zinc electron configuration, right? It has argon 4s, and the 3d is all the way filled up with 10 electrons. Okay, so what happens when zinc loses these 2 electrons, it keeps this full orbital of d electrons. So these 3d electrons stay put, and it loses the valence electrons at the upper energy level, the 4s. They lose those, and that's called a pseudo-noble gas configuration. It happens mostly in this the zinc group, group 12, where it fills up that 3d orbital, and so this still stays filled up, and it's a more stable configuration than losing one out of here and one out of the 3D, one out of the 4s and one out of the 3D. So this is called the pseudo-noble gas configuration. The 3D stays completely full, and we've lost the 2 valence electrons in the 4s. An anion is a negatively charged electron, negative charged atom. Okay, it gains an electron. Okay, so this happens a lot with the halogens, and chlorine's a perfect halogen. Starts out neutral with 17 electrons, 17 protons. It gains one more electron. Okay, so this is the ionization energy that it takes to do that. It actually gives up that energy to do that, and it becomes a chlorine ion. The way I remember what anion is negative is that the N starts with negative. A negative ion is how I remember it. Okay. So these nonmetals gain the number of electrons required to fill an octet. So the group 17, they gain 1, right? That's the halogens. The oxygen group, they usually gain 2. And the nitrogen group, they can gain up to 3. Okay, so when they gain those, however many electrons they gain, they become an ion with however many electrons they gained, that's the negative charge that they have. So most nonmetals, they gain electrons, right, to complete the octet. It's easier for them to gain 1, 2, or 3 than to lose 5 or 6 or 7 to go that way. So they tend to gain electrons, the ones on the right side. Okay, so that's it. That's the end of the video. Short, sweet. You guys should stop the video, pause it, and take notes on this to get your notes down. And there'll be a few questions to answer at the end of the video here.